Hello friends, welcome to Edupedia word videos. In this video, we'll be learning criteria for similarity of two triangles. That is, how we can say that these two given triangles are similar or not. Friends, there are three general criteria for checking the similarity of two triangles. The first criteria is AAA similarity criteria. According to this criteria, if we are given two triangles say they be P, Q, R and A, B, C, then if the corresponding angles are equal, then their corresponding sides will be proportional and the triangles will be similar. Suppose angle A and angle P are 60 degree each, angle B and angle Q are 50 degree each, and angle C and angle R are 70 degree each. So we can see that angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Therefore, this criteria says that triangle ABC is similar to triangle PQR. So literally, if in two triangles the corresponding angles are equal, that is, this set is found, A is equal to P, B to Q and C to R, then their sides are proportional and triangles are similar. So we have two conclusions from this given set. First, that these two triangles are similar, and second, that their sides are also proportional. Now the corresponding sides are AB and PQ because both contain 60 and 50 degree angle at their both ends. Therefore AB over PQ will be equal to, now 60 and 70 is contained in AC and PR, therefore AC over PR. Similarly, 50 and 70 angle is contained in BC and QR, therefore BC over QR. So according to this similarity criteria, if we have the corresponding angle similar, then the triangles will be similar and their sides will be proportional. Now there is a subpart of this criteria which is AA similarity criteria. Friends, we know that in a triangle, suppose we have a triangle M, N and O. If we know that angle M is say 40 degree, angle N is say 60 degree, then we also know that angle M plus angle N plus angle O is 180 degree. That is, sum of interior angles of a triangle is equal to 180 degree. So we can easily calculate angle O, which will be 180 degree minus 40 minus 60. In other words, if we are given two triangles, say A, B, C and PQR, and we are given only two angles, say angle A and angle B as 45 degree, and angle B and angle Q as say 60 degree. So we know that angle A is equal to angle P and angle B is equal to angle Q. But what about C? We will apply this property over here, that is angle A plus angle B plus angle C is equal to 180 degree, and similarly angle B plus angle Q plus angle R is equal to 180 degree. So angle C will come out to be 180 degree minus 45 degree minus 60 degree. Similarly angle R will also be 180 degree minus 45 degree minus 60 degree. Both angle C and angle R will be same, that is 180 degree minus 45 degree minus 60 degree. So we can say if two angles of given triangles are same, then the third angle will also be same because of this constant 180 degree factor involved, and thus the similarity criteria will also be satisfied over here. So the subpart says if two angles of a given pair of triangles are respectively equal, then the triangles are similar. And if the triangles are similar, their corresponding sides, their ratio will also be similar. So this was the first criteria, the AAA criteria, which will show the similarity of triangles and the proportionality of the corresponding sides of triangles of the given pair. Now let us have the second criteria. The second criteria is Sas criteria. This criteria says if corresponding sides of two triangles are proportional, then the triangles are similar, and angles will be equal. By angles we mean the corresponding angles. So according to this criteria, what this criteria says, if we are given two triangles, say the triangles be PQR and TU and V. So if the sides are proportional, say if PQ be 4 and QR be 8 and PR be 10 units and TU be 2, 4 and 5, then the PQ and TU, their ratio is 4/2, which means 2. Similarly, QR over UV will also be 8/4, that is 2. And last but not the least, PR over TV will be 10/5, which is again 2. That is, their corresponding ratios of the sides are same. Hence this criteria, the Sas criteria, says that triangle PQR will be similar to triangle TUV. Now if the triangles are similar, the second part says that their corresponding angles will be equal. Why we have written PQR and TUV? Because PQ is corresponding to TU and QR is corresponding to UV. So their corresponding angles will be P and T, that is angle P will be equal to angle T and angle Q will be equal to angle U. Similarly, angle R will be equal to angle V. So this was the triple S criteria. The third criteria is SAS criteria. By S, friends, we mean side, and by A we mean angle. This S again is side. This was also the case with the previous two criterions. So this criteria says if one angle of a triangle is equal to one angle of other triangle and sides including these angles are proportional, then triangles will be similar. So now let us briefly discuss what this criteria actually means. Let first of all be two triangles let it be ABC and another triangle be P, Q and R. Now if one angle of a triangle is equal to one angle of other, let us implement this statement. Let this time angle A be 60 degree and angle Q be 60 degree, and the sides including these angles are proportional. Now the side including 60 degree over here in triangle ABC are AB and AC. Let AB be 4 centimeter and AC be 6 centimeters. Similarly, sides including here will be QP and QR. If we are taking the side originating from this angle, that is AB and not BA, because AB is originating from this angle, we will also take the similar criteria here, that is we will take QP and not PQ. So let QP be 2 centimeter and QR be 3 centimeter. So we can easily say that AB over QP is 4 over 2, which is 2, and similarly AC over QR is 6 over 3, that is 2. So the sides including this angle is also proportional. So by this criteria, by this theorem, we can say that the triangles are similar. Now what is the order in which we have to write the triangles? See, angle A, the vertices A is corresponding to vertices Q, because both have the angle 60 degree over here. So A will correspond to Q, and what about B and C? BA is the side including 4 centimeter and here it is the side PQ. So P will correspond to B. Similarly, the rest is C, which will correspond to R. Hence, triangle ABC is similar to triangle QPR. we cannot say that ABC is similar to triangle PQR by this criteria, because we have to include the sides which were used in the formation of the angle. So friends, these were some criteria on similarity of triangles. There is also a concept called similarity of triangle formed by an altitude of a right angle. This is a rarely used concept, but let us discuss this concept. The concept says if we have a triangle say P, Q and R, and a perpendicular be drawn at PR at B, and triangle PQR is right angled at Q, and we have drawn a perpendicular QB. So according to this criteria, triangle PQR will be similar to these triangles formed. Let us prove this criteria. Let us first see the triangle PQR and this triangle formed, that is PQB. In both the triangles, angle P is equal to angle P, and angle B in this triangle is 90 degree. Similarly, angle Q in PQR is also 90 degree. So angle B is equal to angle Q. Therefore, by AA criteria, we can say that triangle PQR is similar to triangle P, B and Q. Similarly, we can also apply this criteria in this triangle BRQ. Now if we look at the triangle PQR and the triangle QBR, we can say that angle R are common to both in both the triangles, and angle Q in this triangle is equal to angle B in this triangle, each 90 degree. So by AA criteria, we can say that triangle PQR is similar to triangle QBR. Now from first and second, triangle PQR is similar to PBQ and QBR. Thus we can say that the right hand side of both these statements are also similar, that is PBQ is similar to triangle QBR. If these two triangles, that is PBQ and QBR, are similar, then their corresponding sides must be in same ratio. Now the corresponding sides are PB over QB equal to BQ over BR. PB, QB and BQ and BR. Friends, let me clear that in this order we cannot say that RBQ is similar to PQR. Why? Because the angle of PQR that is this 90-degree Q is corresponding to B, which we can easily judge. So we must use the PQR, the Q vertices with B. But in both the triangles R is common, so the R is corresponding to R. So this R of both the triangles must be in the first position. So by this criteria we can't say that these two triangles are also similar. They can be similar in certain cases, but for sure this order is similar. So moving on to this part, the calculation part, we can cross multiply and we will get PB into BR is equal to BQ into QB. Now BQ and QB are one and the same thing, thus we can say that it is BQ square. So PB into BR is equal to BQ square. So in short, PB into BR is BQ square. Thus in short we can say that if we have a right triangle PQR, right angled at P, and we have a perpendicular drawn from P to hypotenuse, let it be B, then in this case the whole triangle will be similar to these two triangles, and these two triangles will also be similar to each other. And also this hypotenuse, the divided side of these hypotenuse, that is QB and BR, their product will be equal to the square of the perpendicular constructed, that is PB square. So friends, in this video we have learned some criteria of similarity of triangles. First of all, we have learned that AAA similarity criteria, which says if in two triangles the corresponding angles are equal, then their sides are proportional and the triangles will be similar. Then we studied the subpart of this criteria, which exploited or which just used the interior sum angle property of the given triangle. It said that there is no need to check all the three angles. If we can check the two corresponding angles to be same, to be equal for the given pair of triangles, then the triangles will be similar. And if the triangles are similar, their corresponding sides will also be similar. Then we studied the second criteria, the SSS, the side criteria, which said if corresponding sides of two triangles are proportional, then the triangles are similar and the angles will be equal. By angles we mean the corresponding angle. The third criteria and the last criteria we studied was side angle side, SAS criteria. It said that if one angles in the two given triangles are equal and the side including these two angles are proportional, then the triangles will be similar. And if the triangles are similar, all the angles will be equal and their corresponding sides will be proportional. And then we applied this similarity criteria to a right angle triangle. The criteria said that if we have a right angle triangle centered at some point P and we draw a perpendicular PB to the hypotenuse, then the two triangles formed will be similar to each other as well as similar to the whole of the triangle. However, we have to check the order of the similarity, that is in which order this triangle is similar to PQR. Also, the divided part, the product of the divided hypotenuse side, that is QB into BR, is equal to the perpendicular square constructed. So friends, that was some similarity criteria on triangles. In the upcoming video, we'll be dealing with some examples on similarity criteria. Thanks friends for watching this video.